please hit subscribe.
This problem appears at the qualifying examinations for applicants for Japanese government or MEXT scholarships 2020. This problem is from the 2020 physics questionnaire for the undergraduate scholarships. The answer key and original questions are linked in the description. Problem 1 of 1. In figure 1.1, 3 blocks with masses of M, 2M, and 3M are connected and pulled to the right on a horizontal frictionless table by a force with a magnitude of F. Find the magnitudes of the tensions T sub 1 and T sub 2 in the interconnecting chords. Let's now review some key ideas that will be helpful in solving the problem. First is Newton's second law of motion. It says that the sum of all forces acting on a body is equal to the mass of the body times the acceleration of the body. In the problem, we were given forces and masses. So it might be helpful if we assume some form of acceleration in the solution of the problem. And the second idea that we might want to remember is that the tension in a rope or a string is the same throughout the rope or the string. And so whatever the direction of the force that we're looking at, if it is a tension, then it will have the same magnitude whichever direction we're looking at. Now, here we just draw a free body diagram. So the first step, the first free body diagram that I drew here is for the entire system. So we see the box there, that's our body. And we see that it's acted upon by a force. There's only one force, and that's F. And again, because we're going to be using Newton's laws, it's good to assume an acceleration. In this case, let us assume the acceleration to be A. So now Newton's laws of motion becomes the summation of all forces acting on the body, which is just this one. So it becomes equal to F, and F is equal to the mass, the total mass, which is m plus 2m plus 3m. So that's 6m times the acceleration that we assumed, which is just A. Next, we draw the free body diagram for the first block here. And again, there's only one force acting on it, and that's the tension T sub 1. And this time the direction is towards the right. And so if we write Newton's second law for this, again, it's just the summation of all forces acting on this body, and that's only T1. So that summation is equal to T1. And Newton's second law says that that summation is equal to the mass times acceleration of the body. So the mass of this body is m, and the acceleration is the same as the entire body, so that's A. And therefore, actually, from these two equations, you can see the relationship between T sub 1 and F already. Because 1/6 of 6m times A, which is the force F, then 1/6 of F is actually equal to the tension, the first tension, T sub 1. And actually, there's only one choice here that has this option, and so that's letter D. So we'll see that the answer would be letter D. But before we do that, let's just try and see if the second one is the same. So again, let's just draw the free body diagram, and this time there are two forces acting on this block. The force to this direction, T sub 1, and the force to this direction, the tension T sub 2. And Newton's second law says that the summation of all these forces, that means T sub 2 minus T sub 1, the summation of all those forces is equal to the mass times acceleration of this body. So if you write that down, the summation of all forces acting on this body is equal to, well, the summation is t sub 2, that's the first force, and the other force is t sub 1. And we do a minus t sub 1 because they're on opposite directions. And this is equal to the mass times acceleration of this body. So the mass is 2m and the acceleration is a. And so this becomes our equation. But we already know what T1 is, right? T1 is ma. And so we just move T1 to the other side and replace it with ma. And so we are left with T2 equals 3ma. And again, 3ma is 1/2 of F, which is 6ma. And again, that is consistent with letter D out here. Therefore, the answer to this problem is this bit here, letter D. If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!